In today's lesson, we are exploring types of discontinuities, things that interfere with having a continuous function. So, three different types. A jump discontinuity is when we have a break in our graph. And that would often come from having a piecewise function. So an example of that is where we have f of x equals, and maybe it's the function 2x, but only for x values less than 0, and another function negative 1/4 x plus 3, but for x values greater than or equal to 0. And we've been working with these types of functions, so it's continuous in this direction, but then there is a jump. So our graph is not continuous. Okay, the next one is called essential discontinuity. Another word for this is infinite. So infinite discontinuity. And what that is referring to is a vertical asymptote. So we might have that when, here's an example, we have a certain restriction in the domain because of the denominator. So I know that the x value cannot be 2. So then at 2 we would have a vertical asymptote, like that. So then our graph would not be continuous. And the last type is the removable discontinuity, and that would be when there is a hole. So an example of this, if everything's in factored form, so you can see it better, x plus 3 times x minus 4 over x plus 3. So there's this restriction on the domain because of the denominator, but because the denominator can cancel, what that does is it creates a hole at x equals negative 3. So maybe we have this line here, but then at negative 3, we would have a hole. Okay, so we're going to look at 3 different examples where we have discontinuity. So the first one, f of x equals x squared minus 8x plus 15 over x squared minus 6x plus 5. So I've got variables in my denominator. There's a good chance then I have some sort of discontinuity. And what we're going to do is factor the top and the bottom. So this will be f of x equals, the top factors to x minus 3, x minus 5. And the denominator factors to x minus 1, x minus 5. So what is going to happen here, because that cancels, I have just created, so there is a hole, and that is at the x value, x equals positive 5, because positive 5 is what is going to create, I guess it would be down here, create the issue in the denominator. And then if that cancels, we still have more going on in the denominator. So this would be x minus 3 over x minus 1. So because we still have this in the denominator, that is going to create a vertical asymptote at x equals positive 1. And to just give you a visual of the graph, there's the vertical asymptote at 1, and then here would be the hole at x equals 5. Okay, next example, f of x equals 3x over 3x plus 5. So you always want to look to see if you can factor or cancel. In this case, we cannot do that. So we just have to look at what x value might create a problem. If you look in your denominator, 3x plus 5 cannot be 0. So if we just solve for x, so x at negative 5/3, this would be a vertical asymptote. And to give you that quick visual, this graph, and here is your vertical asymptote at negative 5/3. Okay, last example, some trigonometry. So f of x equals cosecant of 2x. And we're only going to find discontinuities over the domain from our x values that are ranging from 0 to 2 pi. All right, well, let's think about this. Cosecant, so that is the same as f of x equals 1 over sine of 2x. So I know that sine of 2x cannot equal 0. So we need to think about the unit circle and think about what values, sine of what values give us 0. And because of this 2x, what I'm going to do is if I go up to my domain, since it's going to be 2x, I'm going to multiply all of those by 2. So I'm going to look at 0. So 2x is going to be in between 0 and 4 pi. Okay, so when is sine 0? So 2x cannot be 0. 2x cannot be pi. 2x cannot be 2 pi. 2x cannot be 3 pi. And 2x cannot be 4 pi. So now if I solve all of these for x, I will have, so I'm going to have vertical asymptotes at x equals 0, x equals pi over 2, x equals pi, x equals 3 pi over 2, and x equals 2 pi. And to give you a visual, here is the graph of cosecant of 2x. And I've got vertical asymptote at 0. And then this would probably be about 2 pi. So within that domain, there are my vertical asymptotes. So there is the full video on exploring types of discontinuities with a higher focus on those vertical asymptotes and holes. Good luck with the lesson.